In this example, we're asked to let P be the point -5, 2, 3, and Q be the point 3, 4, -1, and to suppose that the line segment between those points P and Q forms a diameter of a sphere. We want to find the equation of that sphere. In order to do this, we need to determine the center and the radius of our sphere. Since PQ forms the diameter of a sphere, we know that the center of our sphere is going to be the midpoint of the line segment between P and Q. And so our center can be found using the midpoint formula. In this case, we're going to compute the midpoint by taking the appropriate coordinates of our points P and Q, adding them together, and dividing by 2. So our midpoint will be -5 plus 3 over 2, 2 plus 4 over 2, and 3 plus -1 over 2. And when we do the arithmetic here, we see that we end up getting -2 over 2, which is -1, 6 over 2, which is 3, and 2 over 2, which is 1. And so our center of our sphere will be the point -1, 3, 1. We also need to find the radius of our sphere, and we can do this in a couple different ways. One possibility is to compute the distance between the center, which we now know is -1, 3, 1, and one of the given points P and Q. Here we're going to find the radius as the distance from the center to the point Q. Using the distance formula, we have the square root of 3 minus -1 quantity squared plus 4 minus 3 quantity squared plus -1 minus 1 quantity squared. We can then compute this. This will be the square root of 4 squared, which is 16, plus 4 minus 3 squared, which is 1, plus -2 squared, which will be 4. And we have the square root of 16 plus 1 plus 4, which will give us the square root of 21. So this will be the distance from the center to the point Q. We could have also computed the distance from the center to point P, and you can try this on your own, but you will see that you will also get the square root of 21. Or a third option is to compute the distance between points P and Q, the two given points, and then divide that distance by half, since the center is the midpoint of the two. Again, this will be left to you to check, but the distance in that case would also be the square root of 21. Since we know the center and the radius, we can write down the standard equation of our sphere. In this case, it will be x plus 1 quantity squared plus y minus 3 quantity squared plus z minus 1 quantity squared equals the radius squared, or 21. Now we want to find the equation of the sphere with a diameter PQ, where P is the point located at 2, -1, -3, and Q is the point located at -2, 5, -1. You can pause the video and try this example yourself, then resume the video to see the solution in a few seconds. We first find the center of our sphere, which will be the midpoint of points P and Q. Using the midpoint formula, we see that the center will be the point 0, 2, -2. We then find the radius by calculating the distance between our center and the point Q. Here we use our distance formula, and we find that that distance between 0, 2, -2, and -2, 5, -1 is the square root of 14. And then substituting our radius and center into the standard equation of a sphere, we obtain the equation x squared plus y minus 2 quantity squared plus z plus 2 quantity squared equals 14.